So today I will be showing you how to solve projectile motion problems. The following steps are the general steps to solve it. Number 1, draw a picture. 2, know what to find. 3, list what is given to you. 4, if extra information is needed, solve for it. 5, solve the problem using the 3x5 card equations. The following is an example problem. A car is parked near a cliff overlooking the ocean on an incline that makes an angle of 17.8 degrees with the horizontal. The negligent driver leaves the car in neutral, and the emergency brakes are defective. The car rolls from rest down at the incline and has a velocity of 5 meters per second when it reaches the edge of the cliff. The cliff is 46.8 meters above the ocean. How far is the car from the base of the cliff? Step 1 was to draw a picture, so I drew a picture of a car above an incline of 17.8 degrees, and it is above a cliff that is 48 meters high. Step 2 is to know what to solve for. How far is the car from the base of the cliff? Far equals distance, and base of the cliff equals x. Therefore, we must solve for d of x in meters. Step number 3 was to list what is given to you, and here I split the x and y components. We know that we must solve for d of x. A of x is 0 meters per second. A of y is negative 9.8 meters per second, and dy equals negative 46.8 meters. So, because we know that the car's velocity is 5 meters per second, we can solve for the vertical and horizontal components Vix and Viy using trigonometry and the angle given to us, 17.8 degrees. With this in mind, we can solve for Viy using sine of 17.8 with the equation Viy equals 5 meters per second times sine of 17.8, which gives us velocity initial of y equals 1.53 meters per second. If we do the same to solve for Vix, using cosine of 17.8, we get the equation Vix equals 5 meters per second times cosine of 17.8, which gives us velocity of initial of x equals 4.76 meters per second. If we add this to our list of x and y components, we can see that we don't have enough information to solve for d of x straight away, so we can solve for time for y since they equal the same thing. So if we look at our 3x5 card, we can see that the best equation to solve for time is dy equals Viy times t plus 1/2 at squared, because we know Viy, dy, ay, and need to solve for t. But to avoid using the quadratic formula, we instead solve for Vfy using the equation Vfy squared equals Viy squared plus 2ay times dy. And once we plug in the numbers, we get that Vfy equals negative 30.33 meters per second. And if we add this to our list, we can see that we can solve for time using the equation Vfy equals Viy plus at. And if we simplify that to get time individually, we can get the equation time equals Vfy minus Viy all over ay. And once we plug in our numbers to this equation, we get that ty equals 3.25 seconds. But since time here is equal to both the x and y components, we can add the time to the x column, and therefore we now know enough information to solve for d of x. And we can solve for d of x using the equation d of x equals Vxt plus 1/2 at squared. And once we plug in our numbers, we can solve for d of x, and we get that d of x equals 15.47 meters, and that is our answer.